when looking at a refrigeration system, like the one we have here on the screen, we not only have to think of the thermodynamic cycle or the components or all the different subsystems, but we have to think of everything as being integrated together. And we perform this in AxSTREAM through what we call holistic modeling. In this particular model, I am running a system level analysis that is going to be coupled to a 1D calculation of a geometry-based turbomachinery solver, which here takes the boundary conditions from the system, provides them to the AxSTREAM software to then return the efficiency of these two compressors based on the system operating conditions and based on any parameter that I want to control, like for example here, the inlet guide vane for this particular compressor, as you can see here in the 2D view and here in the 3D view. This means that I don't actually need a performance map to see how that machine and system is going to operate. I can make changes directly on here, and the meanline solver is going to run an analysis on those compressors for exactly the right boundary conditions, so there's no interpolation or extrapolations error due to the use of map. And similarly here, if we wanted to use performance maps as is done traditionally, we would need a family of map for each of the different restagger conditions. Here, what I wanted to do for this particular system with a fixed geometry, although we have the opportunity of doing holistic design as well as holistic analysis, I wanted to be able to see the influence of the restaggering of the first and the second IGV and what the combination of them might give you. And here, if we were to look at the efficiency of the first compressor, we can see that it increases with increasing value of the restaggering for the second IGV. If we were to look at the efficiency of the second compressor, you can see we have a trend that's going to be quite different with a peak here around minus 15 degrees. So if we just look at compressor 1 or just compressor 2, we can't really figure out what's going to be optimum for the system. So for this, one parameter that we can look at is going to be the total power consumption. And here we can see that it actually has a lower value, which is going to be around 905 kilowatt, while there are some points, some combinations of inputs here that are going to reach almost 950 kilowatt. So this can mean some pretty large savings in terms of the power consumptions for your overall system by being able to operate it correctly based on how your exact components are going to work. Now, if we wanted to dig deeper into the heat exchanger, as an example, instead of using a 0D model for the component that we have here, we could actually use a 1D thermal fluid network where that component gets discretized into fluid and thermodynamic, into fluid and heat exchange components to then determine the performances of that particular component. I hope this gives you a good overview of how AxSTREAM can help you through the holistic modeling of your kinds of systems.